Hello, everyone. Welcome back. Today, we're going to learn about parabolas. Explain what they are, kind of where they come from, and then also we'll practice with learning about different kinds of equations for parabolas. So, our goals are to, in first part, understand how a parabola relates to other what are called conic sections, and also then be able to find vertex, what I call the vertex, focus, directrix, and equation of a parabola, and we'll explain what those terms mean as well. So, first, let's take a look at that, what conic sections are. So, you may have heard of these. Okay. So a conic section, the definition it says is a conic section is created when a plane, okay, like a flat plane, like a flat plate, intersects or crosses a right circular cone with two parts. So you better see this in pictures. So you have a cone, like a two-part cone, like two cones pointing at each other. And right circular means basically it's the axis, the middle of the cone is a 90-degree angle with the base. Okay, some cones can be tilted or twisted. These are not. They basically point toward each other. So if you essentially cut across these like a flat sheet, then you can get different kinds of figures by doing that. So if you cut straight across, okay, perpendicular to like the axis, the line that goes right through the middle, you create a circle. Okay. Now, if you cut across one cone at an angle, then you create an ellipse. And so actually an ellipse, a circle is actually a type of ellipse where basically it has to do with the equation in part, but basically it's sorry, looking for the right word. Basically, looks like a circle, but essentially that's the difference, the conic section between a circle and an ellipse. Now, a parabola, then, if you cut it in such a way that basically it's not a closed curve anymore, so you can't, like a circle and a ellipse. If you draw one of those, of course, you put your pen down, you come back to the beginning point. That's not true of a parabola. Okay, so basically, if you increase the angle enough, you get a parabola because it actually cuts across the open end of the cone. And then finally, if your plane is essentially um, parallel to the axis line, the line that runs through the middle, then you create what's called a hyperbola, which is two sides, almost like two parabolas of equal spacing, equal size, and everything going in opposite directions. Okay, let's talk more about the parabola then. So a parabola, and this is one way. If you take other algebra classes, you may learn other ways to talk about parabolas as a graph of a quadratic function. But here we're talking about parabola in slightly different ways. As much it's the same. So parabola is a set of all points equidistant from a line called the directrix and a point called not on the directrix called the focus. Okay, so what that means. So here's a line called the directrix and the focus. Of course, a vertex, you're probably familiar with the vertex. A vertex is where a parabola changes directions. Let's come over here and take a look at a parabola. So the idea, if I make okay, sorry, what's going on here? Try that again. Okay, so let's say that I have just a set of axes. Let's here is my focus. Okay, and this line here is what's called the directrix. Okay, now what this means by being equidistant is something like this. So if I draw a line, in fact, maybe I should simply let me get rid of this axis here. Okay, this might be simpler like this. So basically, let's say I draw a parabola, and what this idea equidistant means is that if I have a line that goes from the focus to the parabola, then to the directrix, these lines have the same length. Okay, if this is correct, that's true here as well, and also up here. So if I go this way, these lines are equal length. Okay, and that's why. So basically, that means it means equidistant. So basically, all the points that are the same distance from the focus to some point on the directrix, that set of points is called a parabola. Okay, now another thing that's interesting about the parabola is let's draw another line over here. Let's draw another parabola. Actually, let's just draw this without the axes. Another interesting thing about the focus, if this is our parabola, It's not the best picture, but you get the idea. So the focus is also, if you have rays that come straight in to the parabola, strike the parabola, then basically they're reflected toward the focus. Okay, and that happens all around. So basically, parabola is such a shape such that any rays come straight in toward the parabola, basically is reflected back to the focus. Now that's important because basically this is the reason why satellite dishes and other things like that have this kind of shape. Also, a lot of mirrors and also flashlights, even some old headlights have this kind of shape. So basically, for a satellite dish, the signal comes in and then is reflected back to the receiver right in the middle. Also, a lot of telescopes, but larger telescopes work this way. And also, some flashlights and either headlights work the opposite way. So basically, you have a light here, and basically, a light beam, this happens in reverse. If it strikes a parabola, it goes straight out. Okay. So that's why a lot of things like that are made in a parabola type shape. So once again, so these are rays that come in and strike the focus. Okay. Now, let's talk about the equation of the basic equations of a parabola. Okay, it's called the standard equation. Okay, so the one you're probably most familiar with is this one right here. So if we have the equation x squared equals 4py, so this is a parabola that opens either up or down. Okay, so it looks like this. Okay, so our vertex, in this case, the lowest point, or where it changes direction, is 0. The coordinate says 0p. Sorry, that's the focus. I'm sorry, that's the focus is 0p. I was going to erase this, change that. Okay, that's the bottom of the vertex. Now the focus right here has coordinates 0p, and then the directrix, okay, has the equation y equals -p. Okay, so that's an equation like this. This one opens either up or down, and if p is positive, it opens up. If the p is negative, it opens down. Okay, now we can also have a parabola tilted on its side, and that has just we essentially replaced the x and y's. So y squared equals 4px, and that looks like this. So once again, we have a central axis. Here's our parabola. Okay, here our focus then is p0, and our directrix is a vertical line. The equation x equals -p. So it's basically symmetry to that. Okay, and so those are our basic equations for a parabola. All right, let's practice with those for a moment. So let's look at some examples, and also say one more thing about this one. And so in a similar way, if your p is positive, then this parabola opens to the right. If p is negative, opens to the left. Okay, let's look at some examples. All right. So let's start out with a basic one. Let's say we have this x squared is equal to 16y. Okay. Now let's kind of classify this one. So this one, um, so this one matches right here. What we want to do then is want to find p. That's going to be the key to finding the focus and the directrix. Okay. And so basically, we're going to use this equation x squared is equal to 4py. Okay. So clearly, so I'll just say so 4p has to equal 16. Everything is the same between these two except 16 and 4p. So that means that p is equal to 4. Okay. And so what that tells us then is that the focus okay, we said is going to be this one. This one opens up. Also, this we know it opens either up or down, and this one opens up since p is positive. So the focus has the equation or the coordinate 0, 4, and the directrix as the equation y equals -4. Okay, so we do a quick sketch of that. Okay, and also this one will also have a vertex at 0, 0. You plug in x or y equals 0, you get 0 for the x. It looks something like this. Okay, so here is our focus, 0, 4, and our directrix is the line y equals -4. Okay, now we can also use Desmos to graph this and make sure that's right. And actually, Desmos can actually graph it just like this. Now, if you want to use your graphing calculator, maybe you'll do it like that. You have to solve for y and graph it that way. Okay, so we can try that. Let's look at Desmos. Okay, so we can do it as x squared equals 16y. Okay, and then our directrix or our focus is the point 0, 4, which is right about there if you label if you want. Okay, like I will for this one. So let's label the point 0, 4. Label that, and then the directrix was y equals -4. Okay, and so you can kind of see that. So this length from here to there is basically be the same as this distance from the focus to the parabola should be the same as the length of the parabola to the directrix. Okay, now you can also solve this for y, and so if we graph y equals x squared divided by 16, it's the same graph. So you can also do it that way. That's the way you might have graphed it using your graphing calculator. Okay. All right. So that's an example then of the first one. Okay. Make sure you can find the focus and the directrix. So this gives you an idea if you're building a parabolic, either a parabolic mirror like a satellite dish or something to use as a headlight, then the receiver, if you're doing like a satellite dish, you want your receiver to be here, so all the rays that come in will be collected at this point, or a telescope works the same way. Okay, let's look at another one. Number 2. Let's say we have this. So y squared plus 4x is equal to 0. Okay, this looks a bit different. It's kind of not in the same form. What you want to notice, though, is we have a y squared and an x to the first power, so it matches this one. So first, let's get the y squared by itself. And we just have to subtract 4x on both sides. It gives us y squared is equal to -4x. Okay, and now, once again, I want to find the focus and the directrix. I'll just abbreviate that, the directrix. Okay, so now we know we need to use this version of the equation. The parabola opens up left to right. Y squared is equal to 4px. And in the same way, if we compare these, this tells us that 4p has to equal -4. And of course, just solve this for p is equal to -1. Okay, so then if p is equal to -1, and that means our focus, okay, also if it's -1, this means this one opens to the left this time, since it's negative. Okay, so the focus is going to be -1, 0. And the directrix, if you notice, the equation is x equals -p. Use semicolons there. Okay, and so that's x equals a -1. Oops, make that better. And so that means it's actually be x equals 1. So if we graph this, and once again, our vertex is going to be at the origin 0, 0. And actually, the vertex of all this form is going to be 0, 0. I didn't write that, but it's going to be the case because you plug in 0, either x or y, you get 0 for the other variable. Okay, so if we graph this, we have essentially an axis running this direction. Okay, and so here at 0, 0 is at the origin is our vertex. So look like this. Okay, and once again, origin is vertex 0, 0. Okay. Our focus is going to be at -1, 0. And then our directrix is going to be the line, in this case, x equals +1. So let's graph that. We can graph it just the way it is. In fact, you can graph it in the original form if you want. Actually, let me get rid of all these. So we have y squared plus 4x equals 0. Okay, you see. Then our vertex, we said, is the point -1, 0. We can label that point. Okay, let's zoom in a bit so we can see it a bit better. And then our directrix is the point x equals +1, -1, +1. Okay, and once we can imagine that, so to look here, in fact, the distance from the focus to this part of the parabola, go up 4 steps, and then you see it's 4 steps from there to the directrix, so that makes sense. Okay. Now, if you wanted to graph this one, what you'd have to do, let's go back to our formula. So you need to solve this for y squared, take the square root of both sides, basically plus or minus the square root of right here, plus or minus the square root of 4x, and we can show you that as well. Okay, and so if you graphed y equals the square root, so just type sqrt of -4x. Okay, you get the top version, and then if we do the same thing in negative, make it negative in front. If you take the square root, you get a plus or minus. Y equals negative square root sqrt of -4x. You get the bottom half. Okay, so doing a graphing calculator might do it like that. That gives you the same graph. Okay. All right. Now let's go back and take a look at some other examples. So what can also happen is your vertex doesn't have to be at the origin. Okay, it can also be at any other point in space. Let's take a look at some examples like that and explain how that works. Okay, so we have two equations, standard equations. So we have one that looks like this. Okay, so once again, the x is squared. We have x minus h squared equals 4p times y minus k. So if you recognize this, basically, if you've seen transformations of graphs, these are basically shifts. Okay, and so if we draw a picture of what this looks like, so this is a vertical axis of symmetry. Okay, it's going to look like this, and our vertex, instead of being at the origin, is going to be at hk. Okay, have those coordinates h and k. Okay, now the focus then, which is right here, is actually going to have the coordinates for this one, h, and then k plus p. So let's see if I can, sorry, let's see if we can make that a bit larger. In fact, let me just write it over here. So the focus, okay, has the coordinates h and then k plus p. Okay, our focus, and then our directrix has the equation y equals k minus p. So basically just a shift in either left or right, up or down, left or right to what we had before. Okay, and we'll see an example of that. Oops, actually I need to move, this is an example we're going to use here later, so I'm going to actually move this down. Just a moment, let me move that down a few pages. We're going to use this one later, example later at the end. I need to get out of the way for right now. Okay. Okay. Then if we can also have an equation the same way with on its side. So what just happened? Hang on, I'm sorry, I'm gonna have to change this a bit. Okay, just a moment. I have to change my layout just a second. And that's not what I want to do either, but we'll have to make the best of it, I guess. Okay, there we go. All right, we're back where we were. All right, so now we can also have a parabola opens up on its side in a similar way. Okay, and that, we look over here, is going to have the equation. This time it's going to be the y part that's squared. So the same form, essentially just switching, um, replacing the y minus k, putting it here, and x minus h, and putting it there. So I have y minus k squared is equal to 4p times x minus h. Okay, and so that's going to be a parabola that opens up either left or right. So we have another axis of symmetry running this direction. I'll just show you open up to the right for now. So our vertex is once again going to be at the point HK. Okay. The focus, I can write this better here. The focus is going to be the point H plus P K. And then the directrix is once again a vertical line, and it will have the equation X equals K minus P. Okay. Once again, and the same things apply to both. So if the P is positive for this one, opens up, negative opens down. Here, if the P is positive here, opens to the right, negative opens to the left. Okay, so once again, let's take a look at a few examples of this. And once again, I need to move this down again. Okay, a second thought, let me just copy it and I'll put it further down, or we'll retrieve it later. And I'll delete it here. Okay, there we go. All right, so now let's take a look at some examples of that and see how that works. And this happened again. All right, once again, bear with me here. I have to do this again. Okay, let's look at some examples. Okay, so let's say we have the focus. We should do a similar thing. So this time, let's say we have this equation. So we have x plus 3 squared equals 5 times y minus 4. Okay. First off, take a look and see which one this looks like. Okay. So obviously in this case, the x is squared, so it matches this one. So we need to find a few things. We need to find p, and also we need to find our vertex. All right. So in our vertex is actually the easiest one to find. In fact, maybe we should write this slightly different way first. Make sure this is clear. So you notice this has minuses in both cases. We can write this as x minus a negative 3 squared is equal to 5 times y minus 4. Okay. So then our vertex is going to be the point negative 3, 4. Okay. Another way to think of it is that basically you switch your sign. So here it's positive, here it's negative, and here it goes the other way. Okay. Now let's find P. Okay. Once again, like here, we're going to use this version. Okay. So x minus h squared is equal to 4p times the expression with y minus k. And here we can see that 4p is equal to 5. Okay, these are exactly the same except for that. And so solve for p, and then p is going to be 5/4. Okay, now, so what we see then is our focus then is going to be the point. So the focus is going to be h, which is -3, and then our vertex. And then this is going to be k plus p. So k was 4 plus 5/4. That's a bit of a pain, I know. And so that's going to be -3, and 4 is going to be the same thing as 16/4. In fact, let me just hang on a minute. Let's change this. Let's make this an 8 so we don't have to deal with fractions. Guess here we don't have to get bogged down with fractions. Let's make this an 8. Okay. And so 4p is equal to 8, p is equal to 2. So it's going to be 4. It's going to be then focus is going to be k plus p. So 4 plus p, which is 2, and that's going to be -3, 6. And then the directrix is going to have the equation. It's going to be y equals k minus p. So 4 minus p, 4 minus 2. And so that's going to be y is equal to 2. Okay. Now let's try and graph that. So let's draw our set of axes. Okay. So our vertex is -3, 4. Okay. Then the focus, so probably looks something like this. I was going to open up. This p is positive. The vertex is -3, 6, so about right here. And then finally, the directrix is the line y equals 2. Okay. Now, once again, we can graph that. So we're going to change this to 8. So let's graph that. Let's just get rid of all these and just start new. Okay. So we have x plus 3 quantity squared. Okay. Is equal to 8 times y minus 4. Okay. And right, so our vertex is there at -3, 4. Our focus, we'll be able to point -3, 6. That's our focus. And then finally, our directrix is the line y equals 2. Okay. And actually, we can see, for example, that's going to be correct. So we go like 4 spaces over to the, like here, it's 2 spaces down to the parabola and 2 down to the directrix. Over here, go from the focus 4 spaces to the parabola, 4 down the directrix, and so forth. So that's correct. Okay. Now let's do another one similar to that, except which opens up on its side. Okay. And this time, let's see, let's have a y minus 3 squared is equal to -20 times x plus 2. Okay. And once again, let's write this. So as you can see, compare this, the one that's y, where y term is squared, looks like this, opens up either left or right. All right. So this is y minus 3 squared. And let's convert this to x minus a -2, make it match that. So then our vertex, h and k, I just make sure you don't get these switched, these reversed. So this k, the h, goes with the x. It's -2, the vertex, and then that's going to be 3. Okay. And then also want to find the focus and directrix to abbreviate that. So first, let's find p. And here we won't write the whole thing again, but basically if we compare, negative 20 is equal to 4p. So 4p is equal to negative 20. And so p then is going to be negative 5. Okay. And all since it's negative means it opens to the left. Okay. So our focus is h plus p. So h, which is negative 2, plus p, which is a plus minus 5 or minus 5, and then k, which is 3. And so that's going to be negative 7 and 3. Okay. And then the directrix is the line x, the vertical line x equals k minus p. Once again, k is 3. Oops, I think it's a typo. Hang on. That should be h. I guess it'd be h minus p. Apologies, that's a copy and paste error. It should be h minus p. I'm pretty sure. Yeah, sorry about that. H minus p. It's h minus p. And so that's going to be h. So negative 2. Careful here, since it's negative. So it's going to be negative 2 minus a negative 5. It'll be negative 2 plus 5. And so x, the directrix is going to be positive 3. Okay, so let's graph that. Well, it's going to, this one has a axis like, well, just do draw a regular set of axes. Okay, so our vertex is negative 7, 3. Okay, I'm sorry, crap, that was our focus. All right, apologize for that. So our vertex now was negative 2, 3. So let me change that. So negative 2, 3. Okay, so it also said opens to the left. So it should look something kind of like this. Okay, the focus then is negative 7, 3. It's going to be over here pretty far. So negative 7, 3. Then the directrix is going to be x equals 3. This vertical line right here at x equals 3. Okay, now let's graph that and make sure that's correct. Graph it on Desmos, make sure it matches that. I'm just going to get rid of all this. So, and we can type it in just the way it was given to us. So we have in parentheses y minus 3 quantity squared, okay, is equal to negative 20 times x plus 2. Okay, so right, our vertex negative 2, 3. So our focus should be the point negative 7, 3. Okay, label that. Their directrix is the line x equals 3. And make sure that looks correct. Okay, and it does. So if we look at our focus, actually something looks kind of off. So let's go back and double check that. Maybe it's written that down wrong. Um, equals 3, negative 2, 3. Take a look at that again. No, that should be right. Um, hang on. Something looks off, doesn't it? Vertex, negative 2, 3. Okay, so look back over here. So our focus is h plus p. Okay, so h is negative 2, p is negative 5. Okay, that's negative 7, 3. All right. Then this is negative 2 minus, and this is, then the directrix is h minus p, so negative 2 minus p. So that's going to be negative 2 plus 5 is going to be positive 3, right? So No, that's correct. Yeah, there we go. Okay. So it's 3, yeah, 5 from there. 5, yeah, we're good. 5 from there. Okay, I'm just looking at it wrong. Okay, good. That's correct. I want to just make sure I didn't make a mistake. Right. Good. Okay. So now let's take another look at another idea. A couple more things that can understand. Um, so let's say we want to find the equation of the parabola. Like another example, different example this time. With this time, I'm going to give you the vertex, which is 0, 0. Okay, and the focus is 0, 10. Okay, so now if you notice this is the vertex, let's notice a couple things. So how can we tell what this is? So first off, it helps us draw like a basic graph to get things started. Okay, so here our vertex is the origin 0, 0, and then our focus is at 0, 10. Okay, so the only way that can happen is if we have a parabola that opens up. Okay, so parabolas look something like this. Okay, and so we know it's got to match basically this form right here. This is one that opens either up or down. Okay, so it has the equation x squared. And I realize I probably should have put in both these cases. Let me actually correct something here. So both these should probably say the vertex is at. So I'm just making a correction here. Make this easier to work with. So I'm going to copy this and paste. The vertex is at 0, 0 in these cases. I said that. I want to make sure it's more clear. Okay. Then I'll just do the same thing and just paste this down for the other one to make sure that's clear to everyone when you look at this in the future. Okay, good. All right. So the equation is x squared. One's open up or down. Opens up, it's like this. X squared equals 4py. Okay. So obviously then to complete this, we need to find p. Okay. How do we do that? Well, let's plug in a point. Now, don't plug in the vertex. If you're wondering why, well, if you plug in 0, 0, you're just getting 0 equals 0, which doesn't tell you anything. So let's plug in the focus. Okay. And so that's going to be x is 0. So 0 squared is equal to, okay. Actually, hang on just a second. Okay. Okay. Actually, let's see. Apologize. I actually need to stop recording just a moment, but I'll be right back. Okay, I came back. Sorry, I was just thinking about something. So actually, we don't want to plug in the focus. I wasn't thinking correctly. But remember, look at our description. It says our focus is the point 0p. Okay. So we're going to use that instead. Okay. So the focus is the point 0p. As this implies that p is equal to 10. Okay. So our equation is x squared is equal to 4 times 10 times y. And of course, that's just going to be x squared is equal to 40y. Okay. And also one thing, I want to find our directrix. So this is going to be the line y equals negative p or y equals negative 10. Okay. So that's how you can use the basic information then to find the equation of your parabola. Once again, sorry about that. I just wasn't thinking about that. So actually, it's not so much wrong to plug in those points. It's forcibly plugging those in doesn't tell you anything. Okay. Now let's look at another example. All right. So I also want to find the equation of the parabola. This is going to be a little bit different. I'll say in standard form of, and we're going to look at this one. So this is going to be a different one, x squared minus 4x minus 2y is equal to 0. Okay. Now, this definitely looks different, and we'll explain this. Okay. So what we're going to do then is a version of repleting the square to make this happen. We'll explain how that works. All right. So now, first off, which version is this? Well, let's take a look at what's squared. Okay. In this case, the x is squared. What that tells you then is that basically we're looking at this equation. So we want to basically write this in this form. Okay. or or may more specifically be in more general form like this, maybe right in this form here. Okay, so this is probably going to be more like this. So it's going to be more like x minus h squared is equal to 4p times y minus k. Okay, more specifically, write it in that form. All right, let's see how we do that. So this can involve something where to use a version of what's called completing the square. Now, you may have seen this before, possibly in um, quadratic functions, changing quadratic function one form to the other. So let me rewrite this and explain how this works. Okay, so first I'm going to move my y term to the other side. So minus 4x, if I add that to both sides, and then move a little space right here. Okay, and this is going to be equals to 2y. Okay, now the idea of completing the square, all right, is what I want is x plus or minus something squared is equal to this other side. Okay, so what I have to do then is I have to add something. I have to add something here and also take it away, because basically I can't, if I can't just add, if I, in other words, have to add something and subtract at the same time. So I'm not changing what the equation means. All right. And so what I want to do then is make it look something like this. Okay, something x plus or minus something squared, and then we'll take care of this side. How that's going to work is what we're going to do is we're going to take half of this number, okay, including its sign, which is going to be -2. I'm going to square that. So basically, you take half of that number, including its sign, and square it. We have to subtract that, add it, and subtract it to both sides. Add it and subtract it here. And this side is still the same for right now. Okay. Now, what that's going to be is x squared minus 4x. Then it's going to be plus 4 minus 4. Okay. Now, what we're going to do now is actually going to add this to both sides. And actually, I probably need to move this down a bit. All right. Now, yeah, I need to do that. So let me move this down a bit. I need a little more space. What I want is, and also that already tells me what I want here. I should have mentioned that here. And basically, once I do take half of that, that's what I put right here. So it'll be x minus 2 squared. So what I do now, if I factor this, this essentially is x minus 2 times x minus 2. You can check that by foiling it out. I'm going to add this to both sides, and this is going to be 2y plus 4. I add 4 to both sides. Now, I can write x minus 2 times x minus 2 as x minus 2 squared. And over here, I'm simply going to factor the 2 out and give me 2 times y plus 2. Okay? And that then is now that equation. So what I can do then, I can actually check this and make sure this is right. Let's go to Desmos, and I'll show you both ways to do that. We're going to graph this both ways. Let me clear these out. Okay, let me type in the original first. So x, and it's a nice thing about Desmos, I can do this in Desmos, x squared minus 4x minus 2y is equal to 0. Okay, that's that parabola. Now, what I said, let's make sure we get the same parabola. I said it's going to be x minus 2 squared is equal to 2 times y plus 2. Make sure we get the same thing. Right, we do. If I turn this on and off, exactly the same graph. Okay, all right, let's do one more of those. Number 2. So this time, let's do y squared plus 6y plus x equals 0. Okay, so similar thing. So first off, so this time, since this y is squared, it's going to be look more like this. Okay, some version of that. Once again, let's move the x term the other side, so subtract x on both sides. I'm going to have y squared plus 6y. And over here, I have minus x. And once again, I'm going to have to add something and then take it away. All right. And once again, put this way down here to make sure I have enough space. What I want out of all this is y plus or minus something squared equals something involving x on the other side. Okay. Now, so once again, what I do is I take half of this number, including the sign, which is plus 3, and square that. Okay. And so that's also what goes right here, plus 3. Okay. Then I have y squared plus 6y, then plus 9 minus 9 is equal to negative x. So this look better. Okay. Now, I'm going to factor this and also add 9 to both sides. So if I factor this, and I actually don't have to factor it, but I'm just showing you how to get from here to there easily. If you factor this, you would have y plus 3 and y plus 3. If I add 9 to both sides, this is equal to negative x plus 9. Okay, now you can see y times 3 and y plus 3 is y plus 3 squared. Now over here, I'm just going to factor out the negative. I have x minus 9, so negative x minus 9. Okay, so once again, let's graph this and make sure you get the same thing. Make sure this is the correct equation. Okay, so go to Desmos, clear these out. And so I have y squared plus 6y plus x equals 0. Okay, there's a parabola. And then I was going to double check what I had. So is y plus 3 squared equals negative x minus 9. So y plus 3 squared equals negative, then x minus 9. And yeah, I get exactly the same graph. Okay, so that's just being to take this and write it in standard form. The reason we want to do that then is once in the standard form, we can here find our vertex, find our focus, find our directrix. Okay, let's take a look at one final problem. Let's take a look at an application problem. And where did I put it? It's right here. So next what I'm going to do is I'm just going to copy it and paste it. So grab it instead of trying to move it. All right. Okay. Let's take a look at this one's application problem. All right. So this one says, it's kind of an example of how this is used. So a flashlight, heavy duty flashlight mirror is a parabolic cross section with a diameter of 6 inches and a depth of 1 inch. Okay. So basically the idea is we want to put a lamp or put a lamp bulb right here. And what's going to happen is the light's going to flow from the focus at the focus. And it's going to go then bounce off this parabolic mirror and go straight out. This is the way a lot of flashlights and also some headlights used to be at least made. Okay. So what to do, part A is find a coordinate system with the origin at the vertex and the x-axis on the parabola's axis of symmetry and find an equation of the parabola. So what that means is for part A, so here's the x-axis, here's the y-axis, okay, with the vertex right here, And so this parabolic mirror is going to look something like this. Okay. Now, what we know about this is we know this is a length of 6 inches from here to there, and also has a depth from the parabola to right there of 1 inch. So basically, these coordinates are, since it's 6 inch, so this goes to 1. So this point, this x coordinate, if this the vertex is right here, is 0, 0, our x coordinate here is going to be 1. And since the total length from top to bottom is 6, this is going to be 1, 3. And down here, this is going to be 1, -3. Okay. Take a look, see if that makes sense again. So we're putting the axis along the axis of the parabola is along the x-axis. Okay. 6 inches from top to bottom, and then from the vertex out to the edge here, it's 1 inch. Okay, so that means our points here are x's goes from 0 to 1, and then from 3 to -3, which is 6. Okay. Now, what we want to do then is find the equation. All right. So we know that we have an equation. The center of the vertex is going to look like one of these. And basically, since it's on its side, it's going to look like this. Okay. And so this is going to be sorry about that. So y squared is 4p times x. Okay. Now here I need to find p. Okay. Now here what I can do is actually I can plug in either one of these points, because here neither one is 0. So once I plug in the origin 0, 0, that's just going to give me 0 equals 0, which is true. It just doesn't help. Okay. So plug in, I'll just pick either point should work. I'll plug in 1, 3. Okay. So y then is going to be 3 squared is equal to 4p times x, which is 1. And so we get 9 is equal to 4p. And so no matter by the space of p is equal to 9 over 4. Okay. So our equation is y squared is equal to 4 times 9/4 x. And of course, we can simplify that. The 4's will cancel out. And I'm left with just y squared is equal to 9x. Okay. Now we can also check that. Okay, let's go back to Desmos. Get rid of these. So let's do that. So y squared is equal to 9x. Okay. Now let's make sure those 2 points are on there. So we said the point 1, 3 be on it. It is. And the point 1, -3 should be on it. And it is there as well. Okay. So got that right. Now let's see what part B was. So part B basically want to find the focus. And so how far from the vertex should the bulb be positioned if it's placed at the focus? Okay. Basically part B, we'll find the focus. And so remember, if you have an equation like this, the focus is just P0, okay? And P, we said was 9/4. And so that's going to be 9/4, 0. So the bulb is placed 9/4. I believe this was inches. So 9/4 of, and also it's approximate that because 9/4 is not the one to use. So 9/4. In fact, you can also use Desmos for that. Let's see. So 9 divided by 4, approximately 2.25, right? Which is equal 2.25 inches horizontally from the vertex. Okay, and so let's go back to Desmos. And if we type that point in, so let's do this, and so we have the point 9/4 0. And let's label that. That should be our focus. Okay. And of course, in our directrix, it asks for that. Then our directrix is going to be the line x equals negative 9/4. Okay. And so that's our parabola with the focus and directrix. So basically, once again, if you place the bulb at this location, it shines here, then basically the light that's shined from the bulb back in this direction, everything will be focused then basically straight outward from the parabola. Okay, so have a summary of what we learned. Is what we learned is basically the basic ideas of parabolas. Okay, so in terms of conic sections, so we learned how parabolas related to other conic sections, and basically learned how to find the equations, what the equations are, the basic equations, and then how to find the equations, how to find the focus, how to find the directrix, and what those things tell us about the parabola. Thank you. Have a good day.